the traffic flowing in opposite direction. As we increase the separation between the two flow of traffic which are in the opposite direction, the confidence of the drivers increase, and hence the speed increase. As we see that on all those highways, we have a big separation between the traffic going in the opposite direction. So that's why we have the vehicles traveling on a faster speed. That's not only because of this, but that since that gives kind of a confidence to the drivers that they won't be hit by the vehicles coming from the opposite direction, so they go with the faster speed. Excess density here. Okay, though the relationship is very, very weak, excess density means the number of driveways that we have, the number of accesses that we have on a roadway. So higher the number of driveways, which are driveways are the cuts. I should say the cuts. The more cuts we have on the roadways, the slower the speed will be, because the drivers won't feel confident while driving on such roadways where we have more cuts or more driveways coming onto the roadway. They might always be thinking that some vehicles will come out of those cuts and then interrupt on their way. So that's why they are not more confident. So as the number of accesses of the driveway increases, the speeds of the vehicles go down. So that's why we see this negative relationship. Segment length. Segment length is actually the length of the roadway between two signalized intersections. So as in the other words, if I say that as the number of traffic signal on a roadway increases, the speed of the vehicle decreases. Or in the other word, as the number of signals of the roadway decreases, or the length of the roadway without the signals increase, the speeds of the vehicle increase, because the vehicles are not being interrupted by the red lights. So the first line in this table tells us the relationship between the correlation between the speeds of the vehicles, which is the dependent variable, and all these independent variables here. These columns tell us the relationship between the independent variable here and other independent variables over here. So for example, posted speed is very highly correlated with the length of the segment, and they are positively related. On the other hand, if we see here, let's see, the excess density, let's say it's negatively related with the posted speed, is negatively related with the length width. So as the excess number of accesses increases, the lane width decreases. The columns, it gives us the correlations between the independent variables and the dependent variables as well. The row, the first row is giving us the relationship or the correlation between the dependent variable and other independent variables. So if you have a problem, or if you want to know, for example, if you create a problem for your dissertation or for your thesis, and you want to see what are the relationships between the independent variable or the variable which is being affected by other variables, you can just go by correlation analysis as well, it's a good contribution, because it at least it shows you how the independent variable is being affected by the independent variables. Sometimes you are not always able to do the regression analysis or create a model. Correlation analysis is also a very good way to show the relationships between the independent variable and the dependent variable. However, it does not give you it does not tell you how the variation in the dependent variable is, like how all these variables are explaining the variation in the dependent variable, which we will discuss shortly. But at least it shows you what is the strength of the relationship between the independent variable and the dependent variable, and whether they are positively or negatively correlated. Now, if you are going for the next one more step further, which is you are going towards regression analysis, this correlation analysis gives you a better idea which independent variables to take in your model and which independent variables to leave. This is one step, like one kind of going forward. What you can also do is that once you collect a small sample of data, let's say due to any reason you are not able to collect more than 30 data points. So you are, based on those 30 data points, you conduct a correlation analysis. And out of that, those, excuse me, yes. Sorry, I don't understand your question. What does this mean? Oh, you mean that the till 40 does not have any negative relation, and after 40 it increases? That is what you mean? You mean that till 40 it does not affect the dependent variable, and after 40 as it increases from 40 it negatively correlates? Well, it depends. Of course, you are right. That is why we are saying a negative sign here. If it is 2, then it's not going to affect, because having 2 driveways, it's not going to affect the speeds of the vehicles. But however, if you have 5 driveways on a 1 mile roadway, which means you have all the developments. For example, there are shopping centers, there are residences which have direct access to the roadway, and if there are 10 shopping centers or 10 shops, which are 10 residences that have direct access on the roadway on a 1 mile stretch, then definitely the speed of the vehicles will be lower, because the drivers they will be a kind of very careful while driving, thinking that any vehicle or any pedestrians may come out of those driveways. So of course, when it's 2, they are not going to affect as much, but as the number of driveways increases, the speeds of the vehicles go down, and that is why we have this negative number. Understood? Yeah, of course it is negative. That's why we have negative here. That's why we have negative here. You see this negative sign? So that is what it tells. So again, I was at the point that, for example, you collect the data about 10 independent variables, you conduct correlation analysis, and you find out that out of those 10 independent variables, only 5 are showing effectiveness or showing strong relationship with their dependent variables. Then you may go back and collect the data for only those 5 independent variables, more data for only those 5 variables, saying that since these are the variables that affect your dependent variables. So that is how the correlation helps you as well. I'll give you an example. Recently, I went to a conference in which I presented a paper, and in that paper I conducted a correlation analysis between all those factors on the roadways that gives more comfort level to the pedestrians. And I presented a table that showed the correlation analysis. And then there was one researcher, he said that, see, this correlation analysis table just tells him that what are the factors. He says that rather than going into the developing complex models, this simple correlation analysis tells the practitioners that these are the factors that positively or negatively influence the pedestrians on a roadway. So this is one first step towards finding out the factors that influence that tells you what are the factors that affecting your dependent variable. So when we'll do the SPSS exercise, we'll see how can we conduct this correlation analysis in SPSS. Now then comes our second, and of course this is our modeling technique. What is regression analysis? Now, if you see in the first bullet, I'm saying that regression is a statistical modeling technique that determines the relationship between dependent variable and independent variable. The first question that comes to your mind is, okay, if the regression analysis tells us the relationship between dependent and independent variables, then how it is different from the correlation analysis? Well, correlation analysis, of course, shows you the strength of the relationship between dependent and independent variables and whether they are going negative or they are going positive. However, it does not give you the value by which it is bringing a variation in your dependent variable. And you will understand it when I'll discuss the equation of the regression analysis. All the variables in a regression model show you how much they explain the variation in your dependent variable. This is a little bit difficult concept, but you'll understand it when we discuss the equation. So the independent variables explain the variation in the dependent variables. How the dependent variable is varying, how they are, and by which quantity, how much is the variation in the dependent variable is, that is explained by the independent variables when we develop a regression model. A regression model can be a linear or a non-linear. So today we'll discuss the linear model. However, SPSS gives you, that's a tool that you can use to develop a non-linear. Linear is the most simplest form. Easy to understand, easy to use. However, sometimes your variables are not linearly related with each other. So for example, if you vary x by 1, then the variation in the y is also by 1. However, this is not always true. Sometimes the relationships are non-linear, which means either they are a curve. In case of a linear relationship, you'll have a straight line, whether going in the increasing direction or going in the decreasing direction. However, in case of the non-linear models or non-linear relationship, you may have curves, you may have different kinds of other models. So regression analysis, linear regression analysis is the simplest kind of a model, which are more preferred, which are very much used. However, there are some problems where the linearity does not explain the variation, and in that case, we need to go to the non-linear relationships or non-linear models. Okay, a regression model can be a simple single variable model or a multiple variable model. Now this means that in a regression model, we can have just one independent variable explaining the variation in the dependent variable. So for example, I would just go and develop a regression model that has vehicle speed as a dependent variable and posted speed limit as an independent variable. Just one single independent variable. That is called simple single variable model. However, if I want to increase the strength of my model, if I want to explain, have a stronger model, or see what are the other variables that can explain the variation in my data set in the dependent variable, then I would add more variables, independent variables, and that is called a multiple variable model, when more than one independent variables are affecting or influencing the dependent variable in my model. In a single variable, that is explained that in a multiple variable regression models, we have two or more explanatory variables that are used to predict the response variable. Now, I'm repeating dependent variable and independent variables. In case of regression, when we are talking about regression, the dependent variable is also called response variable, and the independent variables are called explanatory variables, which means they are explaining the variation in of the dependent variable. So they are also, they could be called independent variables, or they are called explanatory variables when we are doing the regression analysis. So a multiple regression equation can take this form. What is y here? Y is your independent is the dependent variable or your response variable, and in our case this is the speed of the vehicles. Now you see this is beta naught, then beta 1 x1 plus beta 1 x2, so on and so forth, plus this term here. What is beta naught? Beta naught is a constant, which is something which is not being explained by your independent variables. So this is a constant value. x1, x2, x3, so on and so forth, xn are all your independent variables. So in case of our example, x1 could be speed, x2 could be lane width, x3 could be median width, and x4 or xn could be segment length or number of accesses, etc. Beta 1, beta 2, beta n. Beta 1 is called